Okay, so a quick review for those of you who are trying to catch up. We are doing a quick review of exponential functions, y equals a to the x, where it's exponential if the variable is in the base. Restrictions on the base: in order to call it exponential, that base has to be positive and not equal to 1. Because if it is equal to 1, we just get a straight line. You raise 1 to any power and you get 1. It's not that you can't do that, it's just that we don't call it an exponential function, we call it a linear function. Okay, for an exponential function, remember variable always in the exponent. Quick reminder of exponent laws: anything to the power of 0 is 1. When you have a negative exponent, it means you're taking the reciprocal. So, for example, 3 to the minus 1 is a third. 3 to the minus 4, 1 over 3 to the fourth, or 1 over 81. When you have a to the p over q, it means you're looking for the qth root of a to the p. So the denominator becomes the index on the root. The numerator is your power. It is always going to be easier to take the root and raise the answer to the power. For example, 64 to the 2/3 means you're taking the cube root of 64 squared, which is a really big number, and then you're looking for the cube root of it. It is easier to find the cube root of 64, which we know is 4, and then square the answer. Okay, when your base is between 0 and 1, because remember it can't be negative, you have exponential decay, meaning that your graph is going to be a decreasing function. Remember, how do we say decreasing? As I move from left to right, the y values get smaller. What does this look like? Well, let's do it in our head here, a little t-chart. If x is 0, anything to the 0 is 1. If x is 1, I get a half. If x is 2, I get a half squared, a quarter. And we can see what's happening is that this just keeps on getting closer and closer to 0, because we all remember from last year that the x-axis is our horizontal asymptote. So our horizontal asymptote along the x-axis, aka y equals 0. Okay, and if x is negative 1, I've got this. 1/2 to the negative 1 would be, what does the negative mean? Take the reciprocal, the answer would be 2. X is negative 2, I would get negative 2 squared, 4. Negative 3, 8. Okay, so exponential decay, the domain for all exponential functions, all reals, the range, y has to be greater than 0, strictly greater than. We're never going to get 0. That's our horizontal asymptote. We will always have this y-intercept. When x is 0, y is 1. Anything to the power of 0 is 1. Our base is larger than 1. What do we call this? Exponential growth. So you have an increasing function as you move from left to right. Your y values get larger. Quick sketch: exponential functions have a horizontal asymptote. Y is never going to be 0. We have a y-intercept at 1. That is, when x is 0, y is 1. If x is 1, I've got 2 to the 1. X is 2, I've got 2 squared. X is 3, I've got 2 cubed. X is negative 1, I've got a half. Negative 2, a quarter. Okay, so here's our graph of exponential growth. So decreasing function and increasing function. All the key features of that graph: domain, range, intercepts, asymptotes. So note that all of the graphs go through 0 and 1. If your base is a proper fraction, positive fraction, we've got a decreasing function, decay. If a is 1, it's just a constant function. We don't call it exponential. And if a is bigger than 1, increasing. Okay, so as long as a does not equal 1, we've got a domain from negative to positive infinity and a range from 0 to infinity.